kind of not. A past me, does that count? So I'm going to fill in stuff real quick because your notes don't currently have any of the work that you did on Friday. And then if you guys have questions along the way, point them out. Sound good? Go team. On Friday, did you guys grade homework too?
Yes.
Okay. Remind me tomorrow when we go over 8-2 questions if you have any remaining 8-1 questions. So let me know. Sound good? Go team. All right, you guys are so tight today. Wake up, come on. All the loud ones aren't done. Interesting. Without, he's quieter. This is interesting. Is that what it is? Okay. All right, here we go.
More cold.
Sideways. Okay. Kiddos, matrix operations. Matrix is a rectangular array of numbers. This stuff was easy, right? Even though we didn't finish it?
Yes.
Okay. What would we do? What did you do? Or should you do?
5 equals 2.
Yeah, 5 equals 2x plus 1 because in order for matrices to be equal, what? X would equal 2? You guys agree? Does that match up with this one?
Yeah.
Okay, good. If it didn't match up, what would we say?
False.
No solution, yeah. It wouldn't be impossible. How about the bottom one with y? What's y end up equaling? Yeah, 3. Okay, so that's pretty easy cheesy. In order for matrices to be equal, all of their order has to be the same and all their entries have to be the same or have to be equivalent. Okay. What was going on here? We did this one fast, I think, on Thursday with me, right? Why was this one impossible?
They're not the same order.
They're not the same order. Good. Let's review order. How does it work? How do you name this one? Like, what's the order of it?
2-1. A31.
3 by 3, right? The order is like the size. So this would be a 3 by 3. True. What's this one?
3 by 2.
3 by 2. Good. Number of rows and then the number of columns. Long story short, they don't match up. This one does match up, and why is it staying the same? Which means this must be an identity matrix. Wait, what's the identity matrix? Haven't we talked about here?
A plus 0 equals A.
Well, okay, so this would be an additive identity. But the weird thing is, didn't we talk about an identity matrix last session?
Isn't that the reduced row echelon form?
Yeah, and it would go down to all the ones, the main diagonal of ones, and all the zeros everywhere else. Was this one in row echelon form with ones and zeros everywhere else? So this, a zero matrix, is an additive identity, which means, well, what might the other one be? What other kind of an identity do we have? In addition, A plus 0 is A, or it maintains its identity. That's why 0 is called the additive identity. So the other type of identity is a multiplicative identity, because how does that work? A times 1 is A. So that identity matrix we saw wasn't the additive identity, it's the multiplicative one. Interesting. All right, cool kids, what'd you do here? Let me double check your answers. What'd you get for A?
3, -2, 1, 7.
Good, just entry by entry, right? What you have to be careful of on B?
Distributing the negative.
Distributing the negative, and you ended up with?
-1, 0, 3, -9.
Good. You guys all agree? Should be agreed. We should have gotten this one on the video, right? What's the process of C?
Multiply 3 by the whole matrix.
By everything, and what are these individual pieces called? Entries. Good. So basically triple all the entries, right? So you would have ended up with 3, -3, 6, and -3. Good. And then D, just had to put it all together. What do you guys get at the very, very end? After tripling the first one, doubling the second one, and subtracting, distributing the negative to everybody.
-1, -1.
Ooh, I missed you. Sorry. -1, 1.
Negative 1. And then 3.
8 and then -19.
Hi, I think this.
Yeah, I'll put you in. Alright, so far so good? Addition, subtraction, multiplication by a constant. We're doing okay? Alright. What was going on in this one?
Multiply everything by 2.
But you can't just randomly multiply everything by 2.
Factor out the 1/2.
Yeah, it's a better way of putting it. If you factor out the 1/2, what do you end up doing? Remember, factoring is really dividing, right? You're dividing away. And so if you divide by 1/2, Colby, here you go. Then once you divide by 1/2, what do you do on the inside?
Multiply by 2.
Multiply by 2. So multiply by 2 is half the process, right? You guys should have ended up with, good deal, Leo?
Yes.
Okay. Still not too bad, still doing the scalars. There were like some matrix operation properties, addition and scalar multiplication. Hopefully they all made sense as far as transitive and commutative, and you have a little bit of distributive going on. You have an identity one going on. You guys got to this one?
We already did this.
Yeah, good. Here's where I want to make sure you guys understood. How far did you guys get?
Yeah, 36.
36?
I thought we finished.
You already passed 36? Did you guys do the work on?
We finished 36.
36 minutes?
No, number 36.
Oh, you finished that one. Is that where you ended? This is number 36?
Yeah.
Oh, so you didn't finish the whole thing. Okay. Here we go. Shoop, shoop, shoop. So we're right here. Multiplication. Was it trickier than addition and scalar multiplication?
She explained it really well this time.
Yeah.
Oh, go team. Who was subbing for you?
I don't know her name. Oh, yeah. It's
Ashdale. Got it. Okay. So how do you guys do matrix multiplication? She explained it real. Okay, come on.
Cross down.
It's like, I can figure it out. She like did the finger thing.
Do the
crossed
finger
out.
thing.
Okay, finger thing. What's the finger thing?
Go up or down.
Okay, Carl, come show me.
Yeah,
So is that times that
That's right.
Yeah.
times that times the second one. I remember.
It's plus
Times
times
two.
the second one.
Yeah.
You go horizontally and then.
this times that?
No,
Okay, so you're using your fingers and pointing.
It is not.
Right? And you have to keep on going if you need to, right?
Yeah.
So you're going across with one finger and down with the other finger, true?
Yeah.
Okay, thanks. Which means,
Like that?
okay, finger to finger, right? -1 times -3 ends up equaling what? Good, so we have 3. And then what do we do? Add or subtract? Add, and then whatever sign ends up naturally occurring, right? So we have -1 times -3 is +3. What's 3 times -4? Okay. And that's all what comprises the first row, first column, right? Okay, so then what do you do to get to the next one?
Go down.
You go down one? Okay, so when I have -12 and 8, where does that go?
No.
No.
Yes.
And then what would be in the last one?
5 times -3 plus 0.
5 times -3 plus 0 times -4. So -15 plus 0? And how on earth do I get over here though?
You do -1 times 2.
Okay, we do cross down, then we do cross over down. So now we go over. So it's -2 plus 3? We'll get there. What would the next one be? 8 plus. Good. And then the last one? Plus. Good. Now, we're not totally done until we add them all. And some of you can mental math that you wouldn't have even written all those additions, right? But you end up with -9, 1, -4, 6, -15, 10. Do you guys agree?
Yes.
Now, what was going on with the order of these two as to why it was legal to actually multiply?
The columns of A must match the rows of B.
The columns of A must match the rows of B, or another way of looking at it is, what's the order of this guy?
3 by 2.
3 by 2. And what's the order of this guy?
2 by 2.
So what made it legal? These two match. Do these two have to match?
No.
No, just the insides. The insides have to match. The outsides are going to show you what size your answer should be. Do we have a 3 by 2? And the answer is yes. And that way you can make sure that you're keeping track with everything you're supposed to be doing. Now, these ones were kind of small, but as you guys realized, and as Mrs. Ashdale showed, This finger goes across the first matrix, this finger goes down. But guys, why did I do A and then B? Why was A across and B down? Because what product did they want?
A times B.
Question. What would have happened if they had asked for B times A? What? No solution will come.
2 would not have
They don't
matched.
match.
Because B would have been a 2 by 2, right? And what would A have been? A 3 by 2. Is that a problem? What would have happened if we had actually tried to go for it? Now, written this way is going to be kind of confusing. Let me go ahead and write them out real quick. B is your negative 3, 2, negative 4, 1, right? Multiplying by. Do you guys see how even in the process it would have been a problem? I'm going across this way, right? And what am I doing this way? Okay, so negative 3, negative 1, 2, 4. What's missing?
Another thing.
Another term, right? So the reason why we have to have these two match is in order to do our multiplicative process, we need to have the entries corresponding to each other. Otherwise, we'll end up here and it's like, well, that's impossible. But the good thing is, we know it's impossible. And if we didn't know it's impossible, that's a way of double checking it to be like, oh, it doesn't work. Okay, so how'd you guys do on 36? Did you rock it?
No, we were all confused.
You were all confused? Okay, finger trick. First of all, is it legal? What's the size? Good. What's the size? Is it legal?
Yes.
Perfect. What size is my answer, A times B, going to be?
3 by 2.
Okay, so theoretically, if it helps, you could go ahead and set up 3 by 2. Wait, it needs to be longer, right? Okay, I have a 3 by 2 that I need to result in. But hold on, let's just follow our process. Cross down, right? Go across and go down, matching corresponding entries. We're going to try to do the mental mapping since we're honors?
Yes.
What do we got? 0 minus 4, which is negative 4,
Plus 2.
which is? How'd we do?
Good.
Got it? 0, negative 4 plus 2. Negative 2. Now we're going to finish all the down ones. Is that the way you guys were doing it yesterday?
Yeah.
Or Friday? Okay, so what's this one going to be?
12.
12
Plus 0. Plus 1.
plus 12 plus 3 is? Are we okay?
I wrote it down wrong.
Okay. 12 plus 0 plus 3. Okay, your guys' turn. What do I do? Good, which is? Then what?
Plus
Now, if it gets too much, can you just do 14 minus 4 plus 8, get back to it? Okay. But what's that end up being? 18. Okay. Now, it seems like you guys are doing pretty well as long as you remember the cross and down corresponding entries. You're doing pretty well here. My question is, how do we get those answers? Same thing, but I have to now use the...
second column.
Got it. So mental math. 0 plus 5 plus 12. 12 plus 5 is?
17.
Okay. Keep going. So then negative 6 plus 18. Last but not least. So then negative 7 plus 5 is not going to be negative 2. And negative 2 plus 48 is 46. Good. Now are we good?
Yeah.
Kind of. Do we need to practice it and master it probably a little bit better? Yes, but that's why we have? That's due?
Sunday.
Sunday, that's a little awkward. Okay, so, coming back. Although Mrs. Leon sometimes does that. Does she really have it with Maybe it's not Sunday though, maybe that's just, I guess they're all going on their field trip. Anyway, come back. B times A, let's go guys. No solution, because if I do B times A, once again, I have my 3 by 2 times my 3 by 3, and is that good?
No.
No. So we just say impossible, no solution. So So as long as, one more time, the inners match. As long as the rows of the first and the column of the second matches, that way we can have our corresponding cross and down. We're allowed to multiply. Otherwise, nope, nope, nope. How about this one? This is a new example, right? Go team.
Oh, this is my cell.
Ah, 941, we're done!
Is this the 3x3?
No.
It's not a 3x3, what is this? This is a
1 by 3.
1 by 3, remember? Columns and then, sorry, rows. I said backwards. Rows and then columns. Right.
I have an idea.
Good, go.
Alright, so it's 1 by 3, and then you do that by another 1 by 3, and it wouldn't work.
Good.
No solution.
You guys track with what Ryan just said? No.
You're crazy.
A squared is the same thing mathematically speaking as A times A, right? So then we write A and look at it and be like, okay, 1 by 3 times a what? What did we just say? But what's your mind gonna want to do?
Just do it.
Solve it.
941? Wait! When else does our mind want to do something with squaring and it usually makes mistakes and poor little puppies there?
Distributing x plus 2 squared.
X plus 2, I heard it somewhere in the back.
X plus 2 squared.
Does that equal x squared plus 4?
No!
No! What's it equal?
X squared plus 4x plus 4.
And how do you get it?
You foil.
If you don't remember, you can always FOIL, right? Okay, be careful with squares. Don't always just jump to squaring everything you see in sight. That's not always a good plan of action. Okay, so this one is, once again, impossible, no solution, right?
Yeah.
And here's a question. What if it, I don't think this one has one, what if it was possible?
2 by 2.
Yes, you would do it. I'm curious as to how it would look. Ready? Someone give me, let's do a 2 by 2. Give me a matrix with small numbers.
1, 2, 3,
1,
4.
3, 2.
Sorry, baby you. Okay, so 1, 2, 3, 4. Ready, set, practice your multiplying, square it. Go.
Oh no.
Oh no.
This one is possible. A 2 by 2 times a 2 by 2.
Okay. Oh, I already did it wrong.
Then go back and do it right. Hey! Where's our mental toughness? Where's our grit? Double checking I did it fast. 1 and 6 is 7. 2 and 8 is 10.
Yeah.
3 and 12 is 15. 6 and 16 is 22. You guys need to double check. Remember, cross down. First, second, second. First, second, second. And we gotta go over. First, second, second. First, second, second. Are we good?
Yep.
Does that look like what you would have thought a squared would have been? Not even close. Matrix multiplication. Is it something that we're going to be doing mental math, like to get the final answer? No. But are we going to have to do a lot of mental math in between? Yes, or write it out like you saw me do a second ago in this one. Where was he? This guy. You can actually write it out. If we're doing too much, you don't want to be making mistakes, right? Slow down just a little bit. Write out each of the multiplications. But once again, this is not what almost any of us would have assumed a square would have been, right?
Not at all.
Yeah, not at all. Okay. Properties of multiplication. We know multiplication is trickier. We know multiplication is trickier in the sense that its process is much more involved than like just a simple addition or scalar multiplication. So one thing that you don't see, now remember you don't have to memorize these, but one thing that you don't see in any of these, as you're just seeing if they make sense, you don't see the order ever switch. Why doesn't the order ever switch? 2 times 3 is 3 times 2. That works for almost everything, right?
Yeah, but
X plus 1 and X plus 2, X plus 2 and X plus 1.
the matrix.
Matrix is totally different. First of all, we just saw this is sometimes possible when that's sometimes impossible. And even if this is possible, it's going to be a totally different set of multiplications and additions. It's going to be paired up differently, and so therefore the numbers are going to be different. So I wanted you guys to see all these properties, just to see them all, and to see how the order always is maintained. If A is before B, which is before C, that has to be maintained even if we group them differently. If we're distributing A times B and A times C, I have to have the A go first. It can't ever be written second. This is very different than even binomials, polynomials, even like logarithmic functions. Matrices are super unique in this way. So in any of these, you do not see the order switch. You do not see the matrices ever able to switch order. Sound good? Okay, let's keep going. So, ready, set, multiply. Ready, set, multiply. Go ahead and write down the statement. And then use your multiplication as practice to see if you can figure out why this is called the identity matrix. Any picture? Use the screen. Oh, because you don't want her to run it? Whew, is this a rough multiplication, guys?
No.
Oh.
This one you don't. Thinking positive.
He's just thinking positive. He already did it. Oh, he's thinking positive. Positively, technically. Oh, come on, guys, multiply. First, second, third. Go across and go down, right? Show off Mrs. Ashdale's. Trip with the fingers. What do you got in the first element?
3.
Yeah, because it's 3 plus 0 plus 0, right? Huh. What about the second one? Second row with the first column. 1? How about the third one? Ah, not a 1.
Negative 1.
There you go.
Switch.
He's on your paper, isn't it? What's it looking like?
Is it just gonna switch places?
Switch places. Well, that's a good question. Let's keep going. Now what?
2. Oh wait.
Yeah, right? 0, negative 2, and then 0? Now what?
0.
Now what?
2.
King Colby's got a pattern.
5.
You guys fill in the last one.
4. 1. Wait, negative 3.
What happened?
It's the same. It's copied itself.
It copied itself. It stayed the multiplicative identity. So we just call it the identity matrix. It's not the additive identity, it's the multiplicative identity. And the reason it works is because these ones are very strategically placed so that they will go ahead and maintain the original values of the first matrix. And we're kind of used to, because of reduced row echelon form, aren't we kind of used to the ones and then the zeros up and down? But now we see how they help out or how they apply to this whole multiplication thing. So I can show you another one. Oh, wait. Didn't I just say you were never allowed to switch the order of matrices?
Yeah, but there's no message.
Well, okay, so Colby first of all realizes it's not going to be impossible, because 3 by 3 with 3 by 3, if you switch it, it's still possible. But not only is it still possible, for this one matrix, for the identity matrix alone, what's going to happen when we go multiplying this direction? It's still going to stay the same. So what do you multiply, forwards or backwards with the identity? It's the one matrix where either way it's going to remain the same. So guys, look at the very, very top of the page. Do you see what the notation is saying? Given a matrix A, multiplying by its identity matrix. Wait, n. Why does it have an n and an n? Remember we would do the little like n in order to show the order of the matrix in the notation?
Because it has to be something, but it has to be the same as saying.
Yeah, but it has to be by itself. So an n by n, they just put like an n-sized identity matrix. Here's another way of putting it. An identity matrix is always square. I can spell square. Struggle. The identity matrix is always a square matrix. So we only have to think about, oh, it's a 3. Well, I'll probably still say a 3 by 3. You could say I sub 3 for a 3 by 3. And you either do the matrix, the given matrix by the identity, which will, once again, after that multiplication, remain the same. Or the identity matrix by matrix A, it'll once again remain the same. So, its name, identity matrix. Its behavior, technically, it's only what kind of identity again? What operation does it work with? Multiplying. Not adding, because if we added, what's going to happen? So it's not addition, it can only work with multiplication. Okay. Haven't we already done augmented matrices, guys? Where you take a system of equations and we write the coefficients. Oh, but we haven't ever put variables in a matrix. Okay, let me go ahead and zoom in on this for you guys. You might not need to write the entire thing, but let me show you the idea that's going on. Have we been given systems of equations before with 3 equations, 3 variables? Uh-oh. Chapter 7, row echelon form. 8.1, reduced row echelon form. Have we seen systems of equations with 3?
Oh, yeah.
But instead of x1, x2, x3, some of you got confused because what's normally there instead?
X squared.
Okay, x's, y's, and z's. So maybe the variables got us a little confused. But x's, y's, and z's, what are all these little a's? What's going on with all of that?
Their position.
Their position in the matrix. Good. So once we have our x terms lined up, our y terms or our x2 terms, you can name it either way. Our third variable, once we have them lined up, technically when we would do that whole doubly augmented matrix, which you guys don't have to write, but when we would write it with that dotted line, remember him? And we would do, for instance, our A, B, C, our D, E, F, our G, H, I. We would write each of our different coefficients from all of our terms up above, and we would put the constants over here. What was really going on is that, in a sense, we were factoring away all the coefficients, which is way too hard to think about. Maybe it's easier to think about factoring away all the variables, taking the x1, x2, x3, and factoring it out from every one, which we see here in the variable matrix. So we have our coefficients, our coefficient matrix times our variable matrix equals our constant matrix. I don't know if you guys need to write the system down. It's more just the idea of the matrix equation. So we can write a matrix of all of our coefficients times a matrix of all of our variables. And matrix multiplication is what makes this make sense. Because if we were to do our finger thing with the first, the second, and the third, we would get the first equation equal to B1. If we would do the first, second, third with the second row, we would get our second equation equal to B2. And once again, our third equation equal to B3. I just couldn't really show you that before because you didn't know what matrix multiplication was, or maybe better how it worked. Or maybe better how it worked. Let me see. You guys, because I know a few of you are still writing, can kind of check out these two at the same time. I think this is the last example of 8.2. I have a word problem. It's a little random, talking about local dairy mart. We don't really have those out here in the west. In the east, there's more of these. Like, it's called like a milk store, kind of like a dairy store. Anyway. They give us a matrix A and they give us a matrix B, but technically they don't label anything in the matrices like. What are each of these different columns standing for? They give us 2 different matrices. We have to dig into the problem itself to try to figure out, okay, what on earth is, what are the rows, what are the columns? It's pretty important when we go to, you guys see down here, letter A? Interpret.
Types of milk.
Types of milk. Okay, good. We have 3 different types of milk. Where do you guys think, or what do you think that labels? Rows or columns? So we have skim, 2%, and whole.
Rows.
Could be rows.
Either B or 3 rows.
That's a good way of thinking about it. Do you see how in B, there's only 3 of one and there's 2 of the other? Okay, we have 3 types of milk. What's the 2 going to be? Can anybody figure out what the 2 is for?
Numbers of gallons.
The variables. Their price.
Our skim.
For B. For B. For B.
Oh.
Do you guys see the 2? I've heard a couple of different answers. There's only one right one. What would the 2 be?
Price.
Kind of, but isn't price just one?
And the profit.
There you go. So we have 3 types of milk, and then we have the selling price and the profits. So that'd be the price, and that would be the profits. Now, here's a struggle. This one was pretty, not obvious, but this one was easier to deal with because this is a 3 by 3. It's like, wait, what? We don't even know what the other 3 is right now. Let's think backwards, though. There was 2 things having to do with money, the price and the profit. And it makes sense the price is more and the profit is less because only part of that price is profit, part of it's cost or salary or whatever for the people who are working. We have our 2 here. There was 3 types of milk right here. So the question, if these are the 3 types of milk, which one's the types of milk back in this problem?
The roses.
But does that make sense to be the rows again? Look at letter A. If we do A times B, right? We have to think about our order, which is going to be a 3 by 3 times a 3 by 2. What needs to match? So whatever measures this, it's going to have to also measure that. So what does that mean?
The columns.
The rows of one has to match the columns of the other. So then does it make sense that we would have skim 2% and then whole? But what's the other 3 that's going on?
The dairy mark.
Number of gallons. That's what number of gallons is. How many skim milks, how many 2% milks, how many whole milks of gallons, I should say.
A weekend?
Yeah, what's the weekend? That's only 2.
Saturday, Sunday.
Friday.
Yeah, the weekend totally starts on a Friday for businesses, right? So we could say that these are going to be Friday, Saturday, Sunday. Okay, now kiddos, go ahead and just go play with the calculators for a second. I'm not going to make you do this by hand. There are decimals already. But get into your calculators and do that multiplication. That's also practicing, can our calculators multiply matrices? The answer is definitely a yes. Let's see if you can see how it should, how it could, how it can. You guys know how to put matrices in, right? Okay, cool. Let me freeze the screen. I'm going to put it in mine too. Remember, do your A first and your B second, so you have to multiply in that order.
Jeremy?
Yep. Anybody without a calculator, look on someone with a calculator. Where are you guys going right now? Second x to the negative 1, right? Then you're going to edit. Editing A, editing B. A is a 3 by 3, B is a 3 by 2. Careful those numbers, if you plug in one wrong, everything gets messed up, remember?
Big numbers.
You guys have matrix A in there, right? Double checking everything is good.
Yes.
Oh no, back one. How are you guys multiplying it? What are you doing? Yeah, you can just use the plain old multiplication symbol, no stress. Matrix A times matrix B. You guys agree? Question, we have to interpret the result. How do we interpret the result?
It's like the.
Literally just the time symbol up from the home screen. What do we have left over?
It's the order of the
Variables.
So it's the weekend by.
So it's the weekend, so we have Friday, Saturday, Sunday, and then this is going to be my
Cost. Profit.
price, right, and then profit. So then wait, what are they asking in letter B?
Find the variables.
Yeah. Take your profit column and say, well, fine, if you want the total profit, then the profit is going to end up equaling. You guys add, what do you got?
833.2.
Ooh.
How are we doing?
That's a very good.
I added just the profits. But I had to interpret who is who in order to be able to even answer that. But yeah, then I just add all the profits. Kiddos, with that, we're at the end of section 8.2. So we did addition, easy cheesy, right? As long as the orders match. We did scalar multiplication, just distribute in. We did multiplication, wait, process of multiplication when you're doing it by hand is what? Cross down, good.